Okay, let's get started. So before we really dive into everything that we're going to talk about today, I thought I would give us a little bit of just a really quick overview of some very key USD terms. And we'll probably go over this several times today. I know Jeff will cover some of this stuff again when he talks about assets, and I'll, of course, cover it later on today as well. But I thought it'd be a good idea for those of you that might be new to USD to just go over some of these terminologies. I did this back in SIGREF last year, but I did update it a little bit with some better looking assets and so on. So what is USD? Obviously, it's a universal scene description. It's a file format that defines or describes a scene graph. So here's just a quick look at what a scene graph might look like here. And it describes geometry, animation, lights, cameras, and shaders. So it really defines any data that you want. It's really just data underneath. So any sort of data you want to throw at it, it can handle. And what you do is you reference these USD files, or you composite the files on top of one another. A lot of times you'll hear the analogy that it's very similar to how Photoshop works, that as you build up layers in Photoshop, whatever is on top without a mask is covering up what's underneath. So think of that same thing. And I'll probably reference that a couple of times throughout today. How does that help? Well, it's a single place where you can describe your entire scene in one open file format. So it provides it's a rich common language for defining and packaging and assembling and editing your 3D data. It uses multiple, makes it easier to deal with passing assets and so on between multiple packages. It allows for greater artist collaboration in that way. If you can imagine, like, let's take a look at a hypothetical pipeline. So imagine you had one shot. So each shot can be described in a single file. And then there'll be a USD file per department. So the weakest layer could be the layout layer, where the assets they're combined, they're positioned. The next layer may add some characters to the scene from the animation department, which may or may not move something or adjust something in the layout if necessary. And what you're doing, because you're layering that on top, you're giving it a stronger opinion. And then the effects department might want to add some new geometry on top of that. And then ultimately at the end, we're going to add some lighting to that scene. So no matter which department opens up Shot USD, in this case, they see the latest input from all the departments if they want to. So you can imagine that at any point, if you work in layout and you want to see what the lighting is doing, because it could actually potentially affect your layout, or you just want to see what's going on, you can kind of do that at any time. And of course, this is all dependent upon how you want to structure. If you want to use this big Shot USD sort of notion, and we'll see a little bit of that when I do some layout stuff later on. But again, the layout artist can hit render and see exactly what the same output that the lighter would see. So that could help them build better layouts. So let me just really quickly even give more of a practical example of what that could look like. Let's just pop into Houdini. So if you can imagine here that I have my market layout that we'll be using throughout the day today. And then I have some effects that someone had done for me, just taking that tent and isolating the tent, running it through Vellum. And you'll see here that as I sublayered it on top, it was white, it was gray before and maybe not even necessarily in the right location. But now it's taking the stronger opinion of the effects layer that I sublayered on top and is applying anything that's different to it. So it's saying, well, these points should be moving. Doesn't affect the material, because the material we didn't have an opinion on that material. And we'll talk about opinions in a moment. But it is overriding the point positions because we ran a simulation on that. So let's talk about some terminology here. The first one that I want to bring up is layer. And layers are simply a file on disk. You'll hear that a lot. Everything is a layer, basically. inside of USD. So it could be something on disk, and inside of that, it's pointing at another layer. And then once you're inside and you're sub-layering things on top, those are layers that are looking at layers underneath. So a file on disk, character USD is an example. And a stage, the next, it's just a loaded file. The USD composes the stage. So this is because not only on rare occasions is the entire scene stored in a single file, flat file, it's usually lots of different references. There's at least a few layers, like I just mentioned, that could be USD, USDA files on disk, and they're composed together to present the user with a complex view of the stage. And so it is really, like it says here, it's the resulting composition of your layers. Composition arcs is the next term I want to bring up, and composition arcs are basically the operators that allow USD to create these compositions. So it contains mixes of sort of a base scene, any sort of scene description, any sort of overrides that are layered or sub-layered on top of those things. So with USD, it's really important to understand how multiple files on disk can be combined into a single stage or scene graph. Because every USD file contains a complete scene graph for that single object. Even if it's just a table, that USD file contains a scene graph that represents that table. And so the first of these composition arcs that we're going to look at, we're not going to cover all of them today. We're going to cover what are sort of the basic or most important ones, especially for most people. And that first one we're going to look at is sublayer. So you just imagine that one scene graph is laid directly over top of another. If any part of that hierarchy overlaps with the other, then they would, in this case, they don't. So it would simply be a union of the two scene graphs. So each primitive is just defined solely by one USD file or the other. So in this case, like we see here, if we were to combine these two, it's just a union of the other two. So you see not only is every part of set A in that resulting scene graph in the middle, but every part of set B is in there. So let me pop over to Houdini again, and I'm going to show you a bit of a more practical example to that. So just imagine here that we have, if we look at our scene graph here, and I can clear my viewport overrides. So imagine that I have in group A, I have a barrel and a bucket, and in group B, I have a basket and a cooking pot, and that is all merged together in this one particular USD file. So that's my scene graph there, right? And then imagine here, I have another one that is contains a group C and D, and C has a cooking pot in it, and D has some books and some buckets. And I want to sublayer those together. So when I do a sublayer, so I would use our sublayer node, and I drop down and I feed this into the right-hand side, and I want to say sublayer inputs. You'll see that the resulting graph that I have here is exactly what I said. It's just a union of the two. So we have A, we have B, and then we have the union. You can ignore that texture error. It's dropping the texture for some reason. But you get the idea. So now I have this resulting scene graph that is just a combination of the two. So the next term before I go on that I want to talk about is namespace. So it's the path to the primitives in your scene graph. So we saw that just a moment ago when I was playing around with some of these, merging these guys together here. So everything here is a path to those primitives. Represents a location. If you want, think of it as a directory structure. And that's pretty much exactly what it is. And that's important because not only is it important when you sublayer things, but it's also super important when you're referencing things or for any kind of overrides that you want to do when you're dropping down nodes inside of Solaris. You're going to want to make sure you're using the right namespace. And I'm going to mention that a few times today. But to show more of an example of what I mean by that, so we have here, if we look at our scene graph, we have a couple of different groups. So let's bring in another stage that has actually a group B, just like we had in over here, right there. That has our first group B has a basket asset and a cooking pot asset in a particular location. So let's say we have another stage or another USD layer that we want to bring in, and this also has a cooking pot asset, but it has a broom asset. So That's something that wasn't in the other one before. So just to get a look at what the results are of that, we see that, okay, so the cooking pot asset, because we're sublayering this in over top of what we had before, the cooking pot asset is being moved in place of what was there. So if we say, here's our original cooking pot, sorry, there's the other cooking pot, they're in the same place. So the only one we're seeing is the one with the stronger opinion, and that is the one that was in this third node that we brought in. And now we also have on this node, we have a D, which doesn't exist anywhere. So that is just simply laid there on top or union with what was existing already. We could also say, what if we were to take just two of them? So if you imagine here, again, we have A and B, and then I want to sublayer in these two. Make sure I say sublayer inputs, and you see it adds some and then moves some based on whatever is there. So it added a D, but it also moved B over. So I think you're starting to get to understand a little bit about what I mean by namespaces and so on, and how important that is for what you do. So so the next thing that I want to talk about, and I've mentioned it a couple times, and we'll pop that over again in Houdini in just a second, is opinions. And it's basically opinions, by definition, are the atomic elements that participate in value resolution in USD. So each time you author a value for anything, any sort of attribute relationship, you're expressing an opinion for that object in that particular layer. So on a composed stage, any of those layers or any objects in that stage might be affected by different opinions. And there's something that is called strength ordering, which I believe Jeff will talk about later, which determines how USD figures out which opinions are stronger than the others. So just to pop back into Houdini 1 second again. And that's what I meant by when we say here, we have this bucket asset, or cooking pot asset rather. And we also have one here. And because in this particular case, since I'm in Houdini, I'm sublayering. As you're adding, it's becoming the strongest position. So in fact, if I said weakest position and then showed this, then my cooking pot doesn't move at all, because it's what I sublayered in is actually being sublayered in as a weaker to what was there before. So those are important things to think about. Most of the time, you're probably not going to do it this way. I would imagine most of the time you're going to stick to sort of, I don't know, the old-fashioned way, if you can say that about USD. So, and again, same thing here, that we could do exactly the same thing here, and it'll adjust what we would see. So again, these are all things to keep in mind as you're building your layers, but it makes for, like I showed in my example here with the layout and effects, that I want to, I can turn off the ground plane, by the way. That I want to see those overrides, because I'm sublayering this on top. So this is the same thing. I did this in line. By putting this in line, I'm effectively putting this on top of that layer. Okay. So while we're here and we're looking at these layers, there's a couple of other things I want to just point out too. Is we want to make, sort of understanding this stuff as easy as possible. So with Solaris, we do provide some handy tools. So if I click on, say, Shop Back, and I looked at the layer stack, I actually can see every layer that was involved in building out this particular layer, this effects layer. Same thing here. If I click on that and click on any one of those things, you'll see that there's a magic market layer, which is what I brought in. But that is sublayering in or layered on top of the full scene, which was the original USD file that I used to make that particular layer. I can also look here at the composition stack, or if I go over here, we also have the scene graph layers panel. And what's great about this is that while you are working, and we'll see this again later on today, you're able to control what you see in these layers. Like I can go in here and just start turning off, because remember, everything's a layer. So each layer I have some control over what I see, as well as I can turn off the effects if I want. Let's say I don't want to slow my scene down, or I don't want to see the effects at that particular moment because they're not ready yet. And this will constantly be updated. So if you're FX department is lighting or writing to an effects layer all the time, then you'll always be able to get the latest updates as you're working. So as a lighter, you bring in that effects layer, and the idea is that it's always pointing at that latest version. Excuse me. So now the next thing that I want to talk about, that was sublayering. So some key things to point out with sublayering is they're fixed scene graph locations. You can do a sublayer per department, and there's no conflicting edits or sharing issues. Because each department is working in a separate layer, they don't have to worry about sharing that single file and having conflicting edits, because you're sublayering things on top. So if you have a stronger opinion based on that opinion order that you're doing, so when I brought in the effects layer and I put it on top of the layout, that has a stronger opinion. So whatever you're doing in layout, you don't have to worry about messing up what's above too much, or I should say, if you're doing something later in effects, you're not necessarily messing up what is on layer. You're just have a stronger opinion than what's on layer, which can be muted at any time, and the layout portion is left untouched, non-destructive. So the next thing I want to talk about is references. So it's another sort of primary method of combining these USD files into a single scene graph. And unlike sublayering, referencing takes the scene graph of the referenced file and sort of graphs it into a location in the referencing scene graph. So what this means is that the scene graph locations of the reference file are added onto the path into which the file is referenced. So to better illustrate how that works, let me pop into Houdini again. Okay, so what I'm going to do here is, let's say I'm going to reference in, I'm going to take my original stage here, this one here with A and B. And then what I want to do is I'm going to reference in this one over here, that's third one that we had done. And so let's see what my scene graph does. Well, it's not doing anything yet. I need to say reference from multi-input, so it's referencing from that second input there. And so you already see that it just added. It didn't override anything. Like when I sublayered it, it combined stuff. And if there was any overlap, or if there's anything that it has stronger opinion upon or about, that it would put it on top of that. But in this case, it actually just stuck that entire scene graph in a location. Now, when you're saving out references, and I'm sure we'll talk about this later, USD wants to have a default primitive, which is, it's always good to define a default primitive, even if it's like, I could say group A is a default primitive or something like that. And here our reference node is trying to find an automatically chosen primitive, but I can say, well, I want a specific one. So if I control and click on this menu, I can say I want to bring in the broom asset. So that's all I'm referencing in from that. And I can actually put it wherever I want. I can specify, well, let's put it in group A, and we'll even make a new group there. And so now you'll see, or we'll make a new branch or a new path. So you'll see I have group A, I have brooms, and then I have that first broom. We can just say broom A or broom 1, however you want to call it. But you get the idea. So it's putting in that broom asset. It's taking that graph or that scene graph from that asset or that layer that I'm referencing in. I'm choosing exactly which primitive in that I want to bring in, and I put it in a very specific location in my scene graph. So it's a great way to kind of sort of, I think of references as sort of what you want to do at the base layer. So as you're building up, in fact, a stage manager here, when I built this, these are all references. I'm bringing them in and I'm putting them in an exact location. But what I do after that, anything I do with effects layers or anything like that is going to be sublayered on top of that stuff. Okay. Final way of bringing a USD file into, or bringing USD files into an existing scene graph, is through a mechanism called a payload. So it's almost identical to a reference. The only distinction is that it's possible to tell the scene graph to not load the payloads until they're specifically requested. So when files are combined with payloads, it's easy to control which parts of the scene are loaded into memory. So it keeps memory use and processing time down while letting you just kind of load and focus on the parts of the scene that you're interested in. So in fact, if we go back to Houdini for a second. Okay, so you see here, I have that market scene again that I'm sublayering in. And if I look at my scene graph tree here, I can say, let me zoom out a little bit like this. I can go over here and say, where is it? Load all payloads. So I have some viewport controls here for the payloads. And I can turn that off and it unloads everything. That means that everything there was essentially payloadable. It was a payload. And then if I look through my scene graph tree, cyclorama was not. You see the tent as an example is one. You see that it's changed color because it's no longer loaded. I can right click and say load payloads and it'll load that. And I can start to go through and do that for some of the other things as well. Say this, load payloads. So I'm not going to go through and do every one, but you get the idea. But it's a good way to do some management as far as what is being shown in the scene, to keep things efficient. You're only seeing what you want. And there's also other ways to do it as well. If we were using a stage manager node, there's an option up here that you'll see that you can check or uncheck whether to load a payload or not there. So I think, so that about covers that. So that's payloads. So instancing. So obviously, I think we all know a lot about instancing. It's many instances of the same object. So it's just a few same objects or a few objects repeated over and over again. It's kind of like what we used in the market scene for the shelves. So you're instancing all these objects to a bunch of points. And so therefore, it creates what we call prototypes. We'll see in just a second, which are just the objects that are getting instanced onto the points. The important thing to remember is that each instance of each object is the same. You can't override beneath that root primitive of the prototypes, but it can be broken. So later in the day, we'll see some tools that we have that we can use to do things like hero out an instance and affect it, or use it in some way if you want to pick a particular instance and do something to it. So with USD, it works sort of the same as you would expect. If you can imagine here, I am going to actually drop down a point instancer. And then on this side, I'm just going to put some dummy objects. I'm going to use a sock create node, which we'll see more of later today. So I'm not going to talk about it much. But inside, I'll put a cube or box, something like that to make it smaller. And then maybe I'll drag and click and put something new in here. And maybe in here, I'll put, I don't know, put the rubber toy. Make him smaller there. And then I can feed this into this right-hand side of this point instancer. And I can say, well, I want to use the second input. And I want to use, I don't want to use the entire stage. I want to specify. And the reason being is if I use the entire stage, well, then it's going to instance the entire stage to that point, as you see here. In fact, let me just put a grid down. And I'll use that as my points. And so you see it's putting that at each individual, or the entire stage, which consists of the rubber toy in the box, and it's putting it at each point. So it's instancing it at each point. What I want to do is say, I don't want to use the entire stage. I want to specify which ones I want to use, and that can be SOP create one. I actually can use an asterisk here. And it makes it nice, our point instance tool makes it pretty easy to kind of randomize these things in some way. But what I want to point out back to the really USD portion of things is if I now take a look at my scene graph, now you'll notice here, and again, we'll cover this throughout the day. This is more about USD, but I'm seeing some things here that aren't even in the stage that I'm looking at. And that's because it's stored a viewport override. So in order to get rid of that, I want to clear the viewport override. Because once you do some sort of viewport override, we store that for you. In fact, you can even save them out so that you bring them in with your scene anytime you want. But again here, so I only have, we've created what are called prototypes. And what that does is the prototype are the objects that you want to instance onto the points that are just simply contained inside of that point instancer. So next, we're going to talk about variant sets and variants. And so with variant sets, it's a set of alternatives. It's non-destructive. And so just an example here, this is sort of an old example, but these are the carpets. And we had one asset that I brought in, and everything is stored as a variant on top of that. Which is kind of cool. So you can have, a modeler make a bunch of different assets or a bunch of different individual models. And then from that, combine that into a larger asset that contains all of the variants. And you just get to choose which one you want to use at every time. And we will see how that can be helpful later on when I deal with placing books and so on, and barrels and stuff like that. So in fact, in that market scene, a lot of the assets that you saw that compose that scene are assets that have multiple variants to them. And then you can choose the variant and place it however you want. One handy thing about variants, or one thing that could be useful, is you could also use variants to create LODs. So basically what this is doing is this is an HDA that is running through the asset you feed it, and however many LODs you want to create, we're just doing a little poly reduction on it and then storing that LOD as a variant on top of that. And then you can do things like set up something where you say, okay, based on the distance of the camera or based on some other location in space, or as we build these tools, maybe add some more control over that to say, oh, now that I'm further away, I want to be able to, grab whatever variant it is based on a certain threshold that I give it. So here we're going to use a camera, and then we're just going to move that, give it a threshold, and then you'll see in just a moment that as we move away, we get that threshold. As we move past those threshold distances, the auto select LOD tool is going to choose which one to look at. So if we watch at the bottom there, we see that, there we go, it's changing as I get further away. So now real quickly, since we've been talking about variants, I'm going to just quickly show you what it looks like to really take an asset and add a couple variants to that primitive. So I'm just going to drop down a SOP create here, and we'll call it sphere. And if I go inside, I'm going to put down a sphere like this, like so. Let's make it a mesh, something like that. Here's my mesh. And then I want to say add variance to existing primitive because I want to add it to the sphere. And what I want to do is let's feed this into the first side as well as there. And now I'm going to drop down a mountain SOP. Well, first I got to put down a SOP modify. Remember, we're in LOPS right now. And we'll call this mountain 1. Let's go inside, and I want to add a mountain SOP inside of here. Now it's not doing anything. There's a number of things I could do here. I could either do a USD unpack, or I could just go up here simply on here and say unpack USD primitives to polygons. And so now I'm getting my polygons, and I get my mountain. I can do whatever I want there. Change that a little bit. And then I'm going to alt click and drag another one. Let me dive inside here and just do something drastic just for demonstration purposes. And then I also want to make sure that I'm feeding in my original one because I want that to be part of my variants. So you see here that it created a new primitive, but I want the variant primitive to be actually the primitive itself. So if I want to say sphere, put that there. And now you'll see it doesn't work. And the reason why is because some of the opinions of these, and we'll get into this, won't deal with this too much. Maybe Jeff may talk about this a little bit, but the opinions are stronger than or weaker than the actual primitive itself. So what I want to do here, instead of saying, oh, put the variant primitive right on the original, I'm going to use this as a source. I'm going to use the source primitive, or I'm going to set the source primitive to be that sphere. And then maybe here, we'll call this sphere asset. And then right here, I actually want to change this to be just sphere as my source. Whoops. And so now I have my, now I can go in here and change all of my different variants. Here I'm just adding down the bottom here. I'm adding some edit variant nodes. I can also do things like set the variant selection through that or not. So it's using the first one, or it's not using any of the variants. Or I can set it to one of these. I can change the name here. I can say base. I can say mountain 1, mountain 2. And so now, like I said, I have all of my different variants there for me. So that's just a quick look of how I would take something and add. And the reason why I did it with this context options block and adding it to an existing primitive is because if I don't want to just be storing the sphere over and over again with just the different changes. I only want to be storing the changes. And so that's what I'm doing. I'm adding to that primitive. I don't want to make a new primitive or anything like that. It's much more efficient in this case to do that because I'm not actually creating any new geometry. So using variants really is a great way to, have one asset, maybe the model's the same, but you want to just vary the materials and be able to store it and transport it just as a single asset. We'll see that later today with a lot of the objects we use in the market scene. But you can do things like add aging to the texture. So as your sequence progresses, things get older or the plates get dirty or whatever you need. So it's just a great way to work. And I think, you'll find that when it comes to USD, it's good to plan ahead. And Jeff will talk about that today as far as, setting up your assets properly and so you get the most out of USD. And the last little tidbit is Hydra. Hydra is the API that a renderer has to use in order to get the updates from USD. So basically, it's what allows you to see USD in your viewport. So everything in that viewport, like for example, the Solaris viewport is a Hydra delegate. And so that also means that you can have a unified viewport for things like Karma, RenderMan, Redshift. Arnold, I know, has a Hydra delegate. So instead of having separate windows per renderer, you can essentially have it in one single place, and you just choose which renderer you want to use as a dropdown. And of course, we have our new renderer Karma, if you haven't heard about it, and there's lots of others out there. So anyway, that's it for me for this first part. And I am going to hand it over, and I'll see you guys later on today.